Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Today we're doing a absolute beginners session because it's the first Wednesday of the month, and so well, hopefully it'll be suitable if you've never seen Python before. As we go through the session, feel free to ask questions. I'll be watching on the YouTube chat, and I'll also be watching in Slack. There are instructions at the bottom of the meetup and at the bottom of the YouTube video, comments that explain how to get an invitation into Slack. But if you're not on Slack, you can send questions through to YouTube chat. It's just YouTube chat does a bit more censorship, so sometimes I don't see them. All right. So what we're going to do today is look at functions in Python. But really any questions are valid because it is an absolute beginners session. So what we're going to do is use Google Colab for doing our Python, and you'll be able to follow along at home, and there'll be some exercises so that you can work through the exercises. Maybe pause the video for a second while you do the exercise and then start playing again, maybe a bit faster to catch up to where I'll be going live. So to use Google Colab, I provided a link here. That link should also be below the YouTube video in the description below it. So if you click on that link, it'll take you to a new tab and into Google Colab, and it'll open up the notebook that we're going to use. Now you see here it says changes will not be saved, so I recommend copying this notebook to your drive, and then you'll be able to make changes to it yourself. So you will need a Google account to save it to your own Google Drive, but if you don't have that, I guess you can run it without even saving it. Okay, so I'm going to click on copy to drive, and that will open up a new tab, and it will have the words copy of meetup 189. I'll just hide that error message, and functions introduction. So what a Google Colab notebook is a bunch of cells. You can see these rectangles here. There's one cell, here's another one with a rectangle around it, and another one with a rectangle. These have just got formatted text in them. And then when we get down to here, you'll see that we're starting to use Python code cells. All right. So I normally listen on Learning to Code if you want that channel, but you can talk on general as well. So hi, Scott. All right. Now, if you're wanting to run Python, when I first started Python, I got really confused. All the different sorts of Python there were. There was JPython or Jython, CPython. There was Cython, C-Y-T-H-O-N. There was Anaconda, and there was IPython. So, which one should you use? Now, I recommend just using the straight CPython, and what CPython means is it's the Python language written in the language C, which is slightly different to Cython, C-Y-T-H-O-N, which is the Python language compiled into the language C. So not many people use that, especially when they're beginning out. So I would stick to CPython that you get from python.org. But in Google Colab, they give you a version of that which is called IPython, and that's an interactive version of Python. So it gives you everything that you can get with CPython. In fact, it is just straight CPython, but a bit more interactive, so you can run it in a notebook like this, and you get immediate results, and it's a really good way of learning how Python is going. What Python is doing with the instructions that you're giving it. All right, now there's also Anaconda, Anaconda is a sorry, I shouldn't have clicked on that. Anaconda is just CPython with packaged up with a whole bunch of third-party libraries. I like installing third-party libraries separately myself, but if you want just a single solution, then you can install Anaconda and use that. And in fact, when we're using Google Colab, you'll find that all the libraries that are available in Anaconda are actually available to us here in Google Colab. Okay. Now you can put an IDE, an integrated development environment, on your computer as well. I like PyCharm. A lot of people like Visual Studio Code. So there are a couple of good ones. Oh yeah, so these links that we provided here in this first cell, there's a link to this notebook, there's a link to this video, there's our meetup link, and there's also a GitHub site where all these sessions get stored, so you can go back and look through any of the old sessions, and of course the old sessions will have all these links in them as well, so you can go and look at old videos and old notebooks. Right, so how to use Google Colab. You just type into a cell. You see if I hover in between two cells, I can add a new code cell or a new text cell. Then when I want to run the cell, I can press Shift Enter to execute the cell, or I can click on this play button, which says, in fact it says use Control Enter. Control Enter is slightly different to Shift Enter. It runs it and stays in the same cell. Shift Enter will execute the cell and then move you down to the next one, so that's why I use Shift Enter. There's also help available, and so I like to always show you where you can get help, and you can use the question mark. So this is Python code here. It doesn't do much, it's just got hashes in front, which means these are comments, so you can write anything you like after a hash and it'll just be treated as a comment and won't actually do anything. So I had a hash in front of the question mark. I didn't want it just to run automatically, but by taking the hash out, now I can run this cell and you'll see that some help will come up for using the IPython system in Google Colab, and it will come up on the right here eventually. You can see it's just because it's the first command we've given it, it's just connected, give us some RAM, it's got a little computer and some disk, and now we're connected and running, and there's some help on how to use IPython. Alright. Now, writing computer code is it's just about writing commands for a computer to follow. The only computer can do things, they're pretty simple what it can do, but it can do them very quickly and it can do lots of them. So for example, if we want to calculate 5 plus 3 and display the result, we'd put in 5 plus 3, put it in parentheses and after the print command, and you can see it's a different color. That means that's not a comment. All these green bits are just comments. So that's going to do something when I press the play button. So I'll press play, and there it comes up with the result of 8. So that's calculated 5 plus 3 and then displayed the result of 8. That's what you would just normally do in your regular CPython, just your normal Python. In IPython, which we're running here, you don't even need the print command. So you can just say 5 plus 3 or 4 plus 5 and run that. And whatever's on the last line in your code cell, any output from that, IPython will display. Now, if you wanted to display 2 results on different lines, you can do it with 2 print commands just in normal Python, like print 4 and print 3, and it prints on 2 lines. Unfortunately, IPython only looks at the last line, so if I did 2 and 1, there's just 2 expressions, it'll only print out display the last one, which is 1. So the other line didn't actually end up doing anything at all. Alright, so that's just working with some numbers in Python. Now we can store these numbers in memory, and by doing that and then we can name that memory, and those bits of memory where we store stuff are called variables, because we can vary the data that's in them. So for example, I can create a memory location called x, and I can store the number 3 in it by saying x equals 3. So that's all pretty easy. Then I can also do create a memory location called y and store something in y by saying y equals. Now what am I going to store here? I've put a formula in here, and this formula is going to take whatever's in memory location x, multiply it by itself, and then subtract 4 times whatever's in memory location x, and then add 4, and then store the result of all that into y. And then I'm going to display the result. So we run that, we get x equals 3, y equals 1. Now I've used f strings here. This is a Python thing, so it's a strings, anything in double quotes or single quotes, and but because it's got an f out the front, I can actually use these curly braces to evaluate results and show them. And so it evaluates what x is, puts it with x equals and the value 3, y equals 1 in this case. I'm not going to go into f strings too much. They're a really fun and powerful thing you can do in Python, but I've done other sessions on f strings, so look them up. But if you can't understand anything, feel free to ask. Okay, so we can calculate y for different values of x and put all the x and y values into lists. So we create a list using these square brackets in Python, and I'm racing over a few concepts here because we have actually covered them in other beginners sessions, but if you don't understand something, feel free to ask. But I'm finding a lot of people are coming back to these sessions, so they have seen this before. So we create an empty list called list x and list y, and then we just keep appending all these data into them, and and after all of that code, and this is a for loop, so we go around here lots of times. We've got a bit of a conditional in there, which we every 10 rows we're going to actually print the results. So let's run this code, and I hope you're running this on your in your Google Colab, and you should be getting the same results that I'm getting here. So here we go. We've got I is going. We're going through the loop 41 times. So it's going to start at 0 and go up to, but not including 41, so it'll get up to 40. And x will be I divided by 10, and for the first 10 values we're printing out what x and y are, and then we stop doing it after that. And so here you can see our lists. They all look good. We're getting some floating point errors here, which is just something to be aware of when you're working with floating point numbers in Python, that they can round, they can sometimes decimal numbers can't be they can't be represented exactly in binary, which is how these floating point numbers are stored, and so when it displays them again, it doesn't show it as we'd expect. If you really want it to show exactly as you'd expect, then there are other classes other than floating point numbers that you can use. Okay, so we created a list of x values and a list of y values, and I thought I'd just show you how to plot them, because that's always a fun thing to do in Google Colab. We can import this plotly.express, that comes included, and then we can just say plot it using a line chart, so a line between each of the points. You can see as I hover my mouse over any of the points, it tells me what the x and y coordinates are, and we get this curve of the quadratic centered around x equals 2, and so they're all the values that we've just calculated with our function, which was x squared minus 4x plus 4. And there's things that you can do here. You can zoom in by dragging a box around what you want to zoom in on, or a rectangle around it. You can reset back to where you were. Just say click on reset axes. You can pan around by dragging. So it's quite a powerful little charting package, Plotly, and some very nice looking charts. Okay, on to the next cell. It becomes cumbersome and error prone to type x squared minus 4x plus 4 every time we want to calculate y. So what we do is we store it in a function. Even before, I couldn't bring myself to type it out many times. I just put it in a loop to recalculate it. But that's okay if I only ever want to do it in that one loop. But if I want to do it in several places, then I need something a bit more advanced, and that's where functions come in. So to create a function, we use this keyword def. So we're going to define a function. We give the function a name. I've called it f. And then in parentheses, we put any arguments that it might have. So a is an argument. And then we calculate a value based on those arguments, or do something based on those arguments, and then we can return a value if we want using the return command. And you see in Python we've indented return. I've indented it by 4 places, and that's the standard in Python. And so Python works out which lines are inside its function by this indentation. If that indentation was to, if there are a few lines following it and then one of the lines was no longer indented, Python would realize that that line is no longer in the function. Okay, so let's run this, and that'll define the function. And defining, you don't see any results from defining a function, but once it's defined, we can call it. So to call a function, we use a function name followed by parentheses. So here, I've typed the function name f. So that's the function, and then I've put parentheses after the function name, saying I want to call the function, and then I've put inside the parentheses the values of any arguments, and I would separate them with commas if there was more than one, but there's only one here. So the argument I've sent to is 5, and that'll go off and run this function. It'll substitute 5 into the variable a and calculate a squared minus 4a plus 4. So let's run that and see how well it works. And it calculates 9, which is correct. So 4 squared is 16, a5, 25 minus 20 is 5 plus 4 is 9. Okay, so what I might do here, I'm going to share my notebook here that I'm doing in this different user, just so you can actually load this one as well, in case I end up typing some more stuff in here that you might want to catch up with and you miss it being displayed. So anyone with the link, I'll copy that link, done, and I will paste that into Learning to Code. And I'll also paste that to YouTube chat. But if you're following along, you don't need to go to that link. You can just type stuff as I'm typing it. Okay, so now we're giving you a task to do, and I've even given you a spare empty cell here to do this task. And the task is call a function using an argument of 2.5. All right, so you can pause the video now and have a go at this yourself. If not, you can just watch along. All right, so remember the function name is f, so I type f, and then I want to call it, so I put parentheses after the function, and that says I'm going to call it, and I want to give it an argument of 2.5. So inside those parentheses I type 2.5, and then I press play, and it gives me a result of 2.5. And we can check actually if that seems about right. So here's 2.5 here on our chart, and then we've got x equals 2.5, y equals 0.25. So what we got? Yes, y equals 0.25. All right, so how'd you go with that? I hope that that worked for you. And I provided the solution here, and the solution I've done a bit more advanced. I've used variable names to store the results and the input data. I've called the function passing in a variable rather than a literal value, and then I've used f strings for displaying the results. And there we go, solution 1, f of 2.5 equals 0.25. So it gave me the same answer. Right, now Python's dynamically typed, which means that we're using these variables and we haven't said what type of data is being stored in them, and we can actually change. We can put one piece of type of data in there to start with and then put a different piece in later. So here's an example. 3 here is an integer, and that's a particular data type. We store it in x, calculate f of x, and then we display the result. And I'm even going to display the type name as well, and what the results is. So you can see that if I let's run this, and also in this cell we've got x equals 3 dot. Now 3 point is a floating point number, and so we'll see what happens when we send a floating point number to the same function. Okay, so the type of x is, in the first case, is integer, and in the second case it's a float. And then the type of y, which is calculated based on x, is an integer for the first case and a float for the second case. So by using the same function and passing in different data types, we can get a different result. And you can see how Python displays it slightly differently. If it's a floating point number, it'll put a decimal place and possibly a 0, even if there are no values after the decimal point. But for integers, it displays it without a decimal point. So that makes it easier for humans to see whether it's an integer or float, but internally it knows which ones are integers and floats. And I've used the type function here to say what is the type of this variable. And that's a pretty fancy f string I've used to display it. But even that one, like I'm going, oh, I'm typing out this thing twice. And one of the principles of programming is don't repeat yourself. If you find yourself typing out the same thing over and over again, chances are there's a better way of doing it that won't will have less chance of error, and in this case it'll be functions. So we can create a function that does exactly that. It takes we can pass in a function to our function, so a function can be one of the arguments, and we can pass in a variable, and we can, or a value. That value we can pass through to the function and then display the results and what types they are. So let's define that function. I'll run it. Once again, nothing happens until we actually do it. And here we get the same results. I can pass in a 3, and you see here I'm passing an f, and I'm using f without the parentheses, which means I'm passing the function, I'm not calling the function. I'm just using the function as an argument for another function. And there it goes. Actually, I've just noticed in here one problem with this. If I used a different function, I've assumed I've hard-coded in f. Here is the name of the function. I probably shouldn't have done that. I should have called up the name of this function that we've passed in. That's a bit more advanced, so we won't bother with that for now. Okay, task 2. Try calling a function with an argument of a different data type. For example, using the decimal, which is a standard library. And this is the one I was talking about before. If you're having problems with floating point errors, then use a different class, and this is the one you would use, decimal.decimal. So first of all, we have to run that cell to make sure we've imported the library, so now we can use it. And the way we do it, let's say we can say d equals, and what was the name of the library we imported, which is decimal, and then inside that library is a class, and the classes by convention will normally start with an uppercase, and that class name is going to be decimal. And the way we create a decimal is we actually use a string notation, which seems a bit odd to start with. But the reason we do that is because if we were to not put the quotes in, it would suddenly become a floating point number and would be immediately converted to binary, and that's the thing we're trying to avoid, is stop converting it to binary first, because binary can't even store 1.1 exactly as 1.1. So we put 1.1 inside the string, and then we can have a look at what's in D. So I'll run that, and there we go, it's stored D is 1.1, and it displays it like that. If I use the print function, it'll look better for what we need, just 1.1. So that's good. So what's the task? Try calling a function with an argument of a different type, and then okay, so let's use our function. Well, we'll just call it f of d and see what it comes back with. So it passes 1.1 through that formula, x squared minus 4x plus 4. It comes up with 0.81, and it leaves it as a decimal, so it returns it back as a decimal, so that once we start working with decimals, we'll just keep working with decimals, and we don't have any problem with floating point errors. So let's have a look at our solution 2, which uses the print function result function we created before. Input is a decimal in the first case, and we've also done input as a float to compare the two. The output in the first case is a decimal, and in the second case is a float, and the value when we print it is in the first case it's 0.81, but in the second case, using floating point numbers, it's 0.8099996. Alright, so you can see the usefulness of decimal, and the fact that you don't need to rewrite your function if you decide to change over from using floats to decimals, then your functions just keep working in most cases. Alright, task 3, rewrite our loop from before, which created list x and list y, but this time calling the function. Okay. So this will see how well you understand the loops. So I'll copy that from before, and we'll paste that into task 3. But this time, rather than use our function like that, we just put our function name in, f of x, and see how that goes, and it gives us the same results as before. Alright, let's have a look at the solution. Using a function and list comprehension to create lists. So this solution has really compacted the code down to just a couple of lines, and half of the lines are displaying the results. So list x and list y. What it's done, I'll just get rid of this output so we can see. So we've got list x equals empty list y equals empty list. So we'll just look at list x for now. List x equals an empty list, and here we got list x equals a list, but inside the list we've put in a for command and an expression. So we've taken this expression here, I divided by 10, and we've taken the for loop here, stuck that inside the square brackets. And so because that's such a common thing to do, they invented this thing called list comprehension, and so you will see this in Python code. And secondly, to calculate f of y, we just say f of I divided by 10 for I in range 41. That's one way we could have done it. In fact, another way, which is probably even better, we could say f of x for x in listx. That's even simpler, and we can run that. And that creates our list of y and list of x. And we're using a function. Okay, so let's have a look at different sorts of functions. There's some built-in functions, like the print command is a built-in function. It can, so they're called by entering the name followed by parentheses, as I said before. Any arguments need to be included, but in this case we can even use print without any arguments, and that just prints a blank line to the console. And so there's our blank line. We can put in a string, print hello. Okay, what other built-in functions have we already used? So you want to scroll back through the code and see if you can find a built-in function. Really a clue is when you see parentheses. That's normally when you're calling a function. So append is a method on an object, because there's the object dot append, but that's like a function, so we called that before. Range is a built-in function. Now decimal here, that's like a function, but it's because it's a class name rather than a function name, this is actually called a class constructor, and it uses the same format, the parentheses. So it's not really a function, but functions will be called by creating that object. Type, there we go, there's a good one. So type is a built-in function that we can pass any variable into and find the type of that variable. Okay, I think that's it. Let's have a look at the solution. Range, type. Okay, so px.line, that's not a built-in function, but it comes from a third-party library. So we needed to install and then import it. We were lucky that Google Colab had previously installed it for us, so we didn't have to worry about it. But if you're just using normal CPython, you would have to install Plotly to be able to get access to that function. And decimal, we talked about that. It was a class. Yeah. Okay. We mentioned functions don't need to have arguments. So let's create a function now that does something, and this one's we're going to call it show time, and that's going to find out what the current time is now, and format it and display it on our console. So here I've defined the function, and you can see the function contents is indented, and then I've got some lines here which are no longer indented, so it knows that they're outside the function. So I've defined the function and then I've called the function, and this time I don't need any arguments because it just shows me what the current time is, and so it's showing me 2023 September the 6th at 8:02 and 41 seconds and even microseconds. Okay, 8:02, and that will be in Greenwich Mean Time. So Google have given us a server that is using UTC time, and so that's what the time is in UTC. Functions can return values as well as doing actions. So all the print ones we've done so far have been just doing something. The function for the quadratic, that was returning a value. And now we're going to have a play with strings and see if we can do some stuff with strings. So what we want to do is create a function that tells me all the time zone regions that we can get time zones from. And we're going to use a library, PyTZ, which is it's not a standard Python library, but it is included in Google Colab. And it's got a property here, or an attribute, all time zones, that will give us a list of all the time zones. And they'll all come out with names like, you know, Australia/Brisbane. And so we'll look for the slash in them, and the region is what's before the slash. So I'll do a bit of string slicing, and I'm just throwing in stuff here so that you've seen it before. I'm not expecting you to know it or remember it, but by seeing it once here, you know, it might be useful in the future. Sometimes there are going to be regions that don't have a slash, like New Zealand. They just have the same time zone throughout the whole country. So in that case, if there's no slash, then the time zone name is the region. And then we were going to sort them into a list and return that sorted list. Okay, so that's our function, and convert the set of regions into a sorted list. Alright, let's run that. And here we go, here are our regions. Africa, America, Antarctica. So there's Australia, and Australia's got a whole bunch. It'll be Australia/Brisbane, Australia/Sydney, Australia/Melbourne. But we're not after the time zones, we're just after the regions that have time zones, and these are all the ones that are in that library, PyTZ. Okay, so this is getting tricky now. Define a function which takes one argument, the region, and returns the time zones in that region. So let's have a look. I'll create a couple of code cells here. Well, let's do it here. So we're defining a function. It's going to take one argument. What's it going to do? Time zones in that region. Okay. Time zones for region. Okay, that's what we'll call it, and it's going to take one argument, which is the region, so we'll give it the argument name region. Then I put a colon. I should have mentioned on all our previous functions we've defined there's a colon, which basically says we're about to start a code block, the next line of code is going to be indented. And there it is. Google Colab even indents it for us automatically. I think I've got Google Colab set to 4 spaces, but whatever your Google Colab is set to, it might indent it 2 spaces. That'll work too. All right. Return the time zones in that region. Okay, so we're going to have a loop that's going to go through all the time zones. And we're going to put them all into a list. Okay. Time zones is going to be the name of the list. And we're going to check if we're going to check what the region is of that time zone. So we'll use the same code we used before. If slash in time zone, then the region, we'll just call it R, equals time zone up to, but not including the slash. Otherwise, R equals the time zone. Okay. So if the region that we've calculated equals the region that was passed in, then we'll add it into our list. And after going through all that loop, so you see I've taken the indentation back to the loop indentation, so anything from now on won't be in the loop. Now I can just return all our time zones. Alright, let's try that out. So I've indented back to right at the beginning, so I'm outside the function, and let's find the time zones for Australia. Okay, there it runs. So we've got Australia ACT, Australia Adelaide, Australia Brisbane, Australia Broken Hill, and all of those time zones. I think there's more time zones in Australia than any other country in the world. Okay, how do we go with that one? Anyone manage to get that one out? So let's have a look at the solution here. And the solution's starting to look for duplicate code, and you saw how we copied some code and used it slightly differently. So we've extracted that bit of code just into one function, so we can just say what's the region for a time zone and pass in the time zone, and that just does that bit of code. Then we can time zones for region, which is what I wrote this function for, which was quite a few lines. This can be done in one line using list comprehension. So it lists through all of them. It checks what the region for the time zone is and see if it matches region. And so this is a slightly more complicated form of list comprehension than what we did before. Last time we just did the loop. Now we can do the loop and a conditional. So only the ones that satisfy that conditional will end up in the list, and then that gets returned. And then our function before, which had quite a few lines of code, we don't need it to be anywhere near as long anymore. We can put that down to one line. And this time, rather than using list comprehension, we can use set comprehension, and we use the curly braces rather than the square brackets, and then pass it to the sorted function, which will convert it into a list, as well as sort it in order. The other thing you might notice is that when I've defined these functions, the very first line after the function is a string. And it's not a string assigned to a variable. It's just a string sitting there all by itself, and it's using these triple quoted strings, although single quoted would have worked as well. But triple quoted gives you the ability to have several lines in the string. So you start with the triple quotes, and then you have several lines, and then you end with the triple quotes, and everything in between is the string. And that becomes what's called a doc string. So I can run these functions, but I can also get help on these functions that I've created. So for example, I get help on region for time zones. And you see, even Google Colab recognizes it. I hover over region for time zone, and it tells me what it does, extracts the region from a time zone, and by using the same function, we improve the consistency of the data. So it's just taken that from my doc string here. So Google Colab is pretty clever, or the Jupyter notebook that Google Colab is using is pretty clever. So let's run it and see what we get. Solution 5, we get the time zones for the region Australia. That worked. We get the time zones for region New Zealand, and you can see there's no slashes there. We get the time zones for region ETC, which is a way of specifying a time zone just by its difference to Greenwich Mean Time. Or we can also got region UCT for Universal Coordinated Time. I think there's even one called UTC, also Universal Coordinated Time. We can find out the list of time zone regions, which we did before. So there are all the regions. And we can call help on that function, and help displays all these results for us and tells us how the function works. There's quite a lot of stuff there that we've worked out how we can do with functions. Just a warning here when you're using the ETC time zones. This one that always confuses me. So Brisbane is 10 hours ahead of GMT. So if we want to write Brisbane in ETC time, we'd use GMT minus 10, which I guess means if you're in Brisbane and you go 10 hours back, you'll get GMT, which is a sort of backward way of thinking about it. But anyway, that's how it works. So if you want to use it, then that's the one to use. Our help function can be called on even the built-in functions, so they also have doc strings in them. And there's the doc string for print. Okay. And so we're going to talk a bit about the print function. So you see how the arguments of the function can have default values. So here's one of the arguments, a separator, or SEP. If you don't specify it, then it will use a space as the separator. And there's also end for what do you want to print right at the end. And if you don't specify, it'll print a new line. So in Python and many other programming languages, that's how you do a new line, which is \n. It also says where it'll go to, sys.standard out, but you can actually define other places that it will go to. And flush equals false. Whether to forcibly flush the stream, I've never had to call that, so I don't really know why you would call it, but there might be some, especially if you're using something other than sys.standard out, you might need to flush when printing. Alright, so let's try doing a function that's got default values. So we'll write the function with named arguments, and then we'll give each one of those a value, and then when you call the function, you can call it taking arguments by order or by name, and also you can leave arguments out if you call it, and it will fill in the blanks using the default values. Alright, so if we're going to have an argument of minutes and seconds going into total seconds, let's see what it looks like. So there's different ways of calling this. We can call it just by passing in two values, and that's called calling by order. So 32 will go into the first argument, minutes, and 15 will go into the second one, seconds. And it calculates it to 1935. Now you can also in Python call functions by name, and so if you put the name and the value, then it will assign that value to that name. And once you've started doing it by name, every argument after that you have to do by name. But you can do a few by order first and then name second. So here we go. Seconds is 15 and minutes is 32, so it puts 15 into that value and 32 into that, and calculated 1935. And then our last example is calling the first one by order and the second one by name, and once again it came up with the same answer, and just reminding you again that the order ones have to come first. Right, expand total seconds to take 3 arguments. Okay. So let's put hours at the beginning. And you see, by putting it at the beginning, now that's a bit of a problem, because any times I've called that function by order, I'll be now calling it the wrong way. So when you're calling functions, often it's a good idea to call it by name, so that if the arguments change later, then you'll still be calling the function the correct way. Or alternatively, don't change a function by adding something to the beginning. Always add extra arguments to the end. But in this case, it would look silly to go minutes, seconds, hours. Alright, so that's all. I could put in some doc string there for what hours are, but I can run that, and I've defined it, so that now works. So let's have a look at the solution where it does exactly the same thing as I've done. It did the doc string properly, and it's got some examples. So let's run the examples and see how they go. Yep, 0, 32, 15, 1935, just like before, and that's calling by order. Calling by name also worked without providing any of that value for hours. So see, we didn't need to make any change to this one. We were calling by name, and it still works. Calling by order and name with the order first, that still works, but we do have to make sure we put a 0 up the front for our hours. And once again, calling all by name and in a different order, that works, and it adds an hour into the number of seconds there. Alright, task 7, let's define a function which converts the temperature in Celsius to Fahrenheit. So this is a nice simple function, so it's a good exercise for you, so have a go at this one. I've given you a blank cell, so let's go. We'll call it define FAHR, and it's going to take in an argument C for the Celsius value. So I start with DEF to define the function, I give it a name, and then parentheses the argument values. And then the colon at the end says about to start a code block, which is going to be indented. And we can put this all in one line, so I may as well start with the return value. Return C times 1.8 plus 32. And then I can call it. So what's the Fahrenheit value of 0 degrees Celsius? And it's 32 degrees Fahrenheit, and that's correct. Alright, let's have a look. Here's a solution. Once again, this is done proper docstring. Returned value is given a more meaningful name to the argument, so that's a good thing. A good full name for the function name, so it's unlikely that you'll misunderstand what the purpose of the function is. And it's then done a few tests. 0 degrees Celsius is equivalent to 32 degrees Fahrenheit, just as we tested, so that was right. 100 degrees Celsius is 212 degrees Fahrenheit, and I always like this one, minus 40 degrees Celsius is equivalent to minus 40 degrees Fahrenheit, and that just tells me that I've got everything right. Alright, so that's a good introduction to functions. Have you any questions about that? I might just add, we've got a few minutes left, so I might just add, sometimes you'll have a function. Remember our total seconds, our function needed hours, minutes and seconds. Well, we can actually assemble those parameters into a dictionary. So let's create a dictionary, and it's going to have hours in it, so we're going to have 1 hour, and let's say seconds, 1 second. Alright, now we want to use those as the arguments into the function. So what I can do is I can use the explode notation. So I can say, what are the total seconds? Now, I could go hours equals D hours, seconds equals D seconds, and it should be 3601. That's correct. But sometimes I'm not even going to know which ones are provided, so then I'm going to do if statements and try to work out which ones are which. But the really easy thing I can do is I can just go take the dictionary D and explode it out to parameter names. So it'll be and that gives me the same answer, 3601. So sometimes if you see 2 asterisks like that in the code, that means that I want to explode a dictionary out to and pass them in as the arguments to a function. Similarly, I could have a list of arguments. Say I wanted 1 hour, so this I'm calling by order, 0 minutes and 1 second. Let's actually, we'll go 1 1 1. In fact, let's go 2 3, so we can see it's doing something different. So I want to pass them through as the arguments. Now I can't pass them through names because I don't know what the names are from the list, but I can still explode it. And this, because it's just a list, it just takes the single asterisk, and I call it, and there we go, 3723. So that should be 3600 plus 120 plus 3. That's the number of seconds in 1 hour, 2 minutes, and 3 seconds. So I thought I'd just mention that because the first time I saw that coming to Python, I've never seen it in any other programming language, so it caught me by surprise. All right, I hope you enjoyed it. If you like the video, click like and subscribe to my channel, and so you'll get notified when I'm putting up more ones. Next week we're going to be looking at Plotly. It'll be a repeat of the in-person session that we did at Brisbane Business Hub in the Queen Street Mall in Brisbane. So if you went to that and you had some questions, feel free to come along, or if you missed it, I'll go through it all again and you can ask questions online. Our next in-person session is going to be September. So it's going to be in September. Let's have a look. September the 27th, and that'll be on Python, installing Python and using Git, Visual Studio Code, and PyEnv and Streamlit. So PyEnv is a way of keeping control of your Python environments, and working with virtual environments so you don't pollute your main Python installation when you're working on different projects. Streamlit's a good way of converting machine learning data into an application, and we're going to Amazon Web Services is going to provide free pizza for us all. So hope you can make it to that. I'd love to see you there. Thank you.